All right, guys, so in 2.6, we're going to be looking at two different types of special functions. The first one is called a piecewise defined function. Piecewise means that they're kind of separate pieces of different graphs put all together onto one graph. So you can see, if we look at this first example, f of x is defined as being two different functions. It's the function x minus 1 for these specific x values, and then it's the function -1 for these specific x values. So it's almost like someone cut and pasted different graphs like onto the same coordinate system. So you're going to see what they look like when they're done. So we're going to set up a graph right here. So 3 is kind of our splitting point. So 1, 2, 3. So we've got from x is less than or equal to 3, and then x is greater than 3. So you're going to have one graph over here and then a different graph over here. Okay, so let's start with this one. So what you want to do basically is you want to look at this value and see where this function would be when you plug in this x value. Okay, so if we plug 3, so like 3 is kind of our defining piece. If this was 4, we'd be plugging in 4. We're plugging in whatever this value is right here. So we're going to plug in x equals 3 into this first function right here. So x minus 1 becomes 3 minus 1, which is 2. So that means the first one has an ordered pair at 3, 2. Okay, so this is less than or equal to 3. So we're going to plot the point 3, 2. And it's going to be a closed point, because that has the or equal to. Okay, kind of like when you're working with a number line, closed and open are the same as having the or equal to or not having the or equal to. Okay, so plot a closed point, and then from there what we're going to do is we're going to take a look at the slope. Okay, so this is the first function. So like here's the first one, here's the second one. So for the first one, we start with our starting point right here. It's closed because that has the or equal to, and then the slope of this line is 1. Technically, there's a 1 in front of that x. So the slope is 1. So what you do is you go off to the right, you pick any arm, you go off to the left since it's less than or equal to 3, and we plot a slope of 1. So for a slope of 1, we're going to go down 1 over 1, down 1 over 1. We can do it one more time, down 1 over 1, and then you're just going to connect the dots and make a graph. Okay, so it extends forever off to the left because it's anything less than or equal to 3. So I could plug in 3, 2, 1, 0, any negative number. So it keeps on going forever off to the left, but it stops right here when I get to the 3 because that's the boundary that I have right here. So for my second piece, I start at -3. And since this is a -1, just a -1, this is actually a horizontal line. Okay, so it is a horizontal line at -1. That means the function is always -1, no matter what you plug into it. So we're still starting at 3, but see how this is a greater than 3, not a greater than or equal to. So we're going to start at -1, but we're going to start there with an open circle. So open circle, and then from that point on, it is just a horizontal line where the value is always -1. So this is our first example of a piecewise function. So hopefully you can kind of see what I mean when I said it looked like it was literally, a cut and pasting of different functions onto the same coordinate system. So here's the graph x minus 1, but just up until we hit 3. And then here's the horizontal line -1, starting at 3 and then going beyond that point. Okay, so that's the first one. Let's look at the next one. Next one, we've got 3, and we're going to, I'm sorry, I missed something on here. Domain and range. Domain and range, so we're talking about all the possible x values, all the possible y values. So the domain with these, it's always going to be all reals. You can at some point find a place to plug in every possible x value. So here, combining these two ends up covering every x value ever. And then the range is the part that gets a little bit tricky. Once you've got the graph in front of you, you should be able to see what y values are getting hit and what y values are not. So you can see, I would kind of scan up and down, see if there's a high point and a low point. So this is the high point. You're never going to have a higher y value than this. See, there's nothing plotted above this point. And then this arrow means it goes down forever. So 2 is the highest possible point, and then it goes down from there. So you would say that you can hit anything less than or equal to 2. You can hit 2 and anything lower than that, but never anything above that. So that's the domain and range. Okay, now let's look at example 2. So we've got 3 pieces for this one. So let's set up a big graph and we'll start to look piece by piece. So for piece number 1, 0 is kind of your cutoff point, so we're going to plug in 0. So we plug it in, x over 3 becomes 0 over 3, which is 0. So when we plugged in 0, we got 0. So that means we have a coordinate point at 0, 0. So let's start there. Okay, we're going to plot this point right here. We have less than or equal to, so it's going to be a closed circle. And then less than or equal to means we graph off to the left. Now let's take a look at slope. X over 3 is technically like 1/3 times x, so our slope is 1/3. So what we're doing to get more points is we're going to go down 1 and then over to the left 3. That's 1 point. Let's do it one more time. Down 1, over to the left 3. There's another point. Okay, so our graph goes off to the left. Arrow means it goes off forever, because anything less than 0 means it just keeps going and going in that direction, but it stops once it gets to 0, and we have a closed circle, because that has the or equal to right here. Okay, next piece. So here's our first piece, second piece, third piece. Our second piece is the 2x minus 6. So we're actually going to plug in both of these points. So remember the 3-piece inequality means everything in between. So it's going to be in between 0 and 2. So it doesn't go on forever in both directions. It's just going to be trapped between the 0 and the 2. So we're going to plug in the 0. So we plug in 0 right here. So 2 times 0 and then minus 6 leaves us with negative 6. So you have the coordinate point 0, negative 6. So let's start with that. So right there. Now at 0, there's no or equal to, so this is going to be an open circle. And then let's connect it to the 2. So next, we plug in the 2. So 2 times 2 is 4, minus 6 is negative 2. So our second ordered pair is 2, negative 2. Okay, so that is right there, and that's a closed circle because this does have the or equal to. And now 3-piece inequality means it's just connected between those 2 points. So we just connect the dots, and that's it for a 3-piece inequality. And then we have our last piece that goes to the right from 2. Okay, so this is just 1. There's no x in there at all. So if it's just a number like that, then it's going to be a horizontal line. Okay, so horizontal line at 1. So it picks up at 2, so go up to 1. We start here with an open circle because that does not have the or equal to, and then it just goes on forever off to the right. So 2-piece inequalities will always have arrows going off to one side. 3-piece inequalities will just be a segment like that, just trapped in between the 2 pieces. Okay, so that's the piecewise function.